Hello students, welcome back. We completed up to section 2. Now let's go to section 3, methods of proof. Here's a rough classification. We can classify proofs as direct proof and indirect proofs. And among the direct proofs, most typical are proof by algebraic manipulation and proof by logical implication. There are more with some very strange Latin names, but I don't think it's worthwhile. For indirect proofs, the most typical are proof by contradiction and proof by induction. Are there any more? Some strange Latin names? Frankly, I don't even know, so probably they are not very important, even if they exist. We're going to talk about these four. First, proof by manipulation. Let's begin with this example. How do you prove this? You can start from the left-hand side and algebraically manipulate, and then in the end, you're going to get to the right-hand side, like this. This is an example. Here, please pay attention to the specific grammatical rule to write a proof. Please note that all these equalities are well aligned here. All aligned, and then we have the reasoning here, which of course is better but not really absolutely necessary. And as for the alignment, if you use handwritten text, then it's natural to have some squiggly or snaky kind of alignment, so it's not too much of a deal. Really important part, the absolutely important part is right here. Let's go to the graphing mode. Please note that this part is empty. So we don't have any left-hand side and right-hand side, left-hand side, right-hand side, left-hand side, right-hand side like that. We only have the left-hand side here up front, right here, and that continues to the first line, and then the second line, and then the third line. Third line is equal to the second line is equal to the first line, and they all refer back to the left-hand side right here. So they're all the same. So this is actually a one long horizontal identity, but it's too wide, so we are using several lines. This is not three different equalities, just one equality connected. That's the grammatical rule. That's how you do the proof by manipulation. Let's look at another example. Let's get out of this graphing mode. Here's a second example. Prove this. This time, we're going to start from the right-hand side. Manipulate. Eventually, we are going to get to the left-hand side, like this. Again, please note that all the equalities here are aligned. And then we have the reasoning. Certainly this will improve, but that's not really the absolutely necessary part. Really absolutely necessary part, right here, stays empty. So the third line is equal to the second line is equal to the first line, and the first line refers back to the original. So this original left-hand side is the same as original right-hand side. As a matter of fact, I said it backward. Original right-hand side is equal to the original left-hand side. That's how you can do the proof by manipulation. Here's another example. A little bit tougher example, a little bit more general case. N value is 2, then you're going to get this. And this one is a little bit more general. Again, start from the right-hand side. Break up, manipulate, simplify. After a lot of cancellation, we get to the right-hand side. Please note that all the equalities are aligned and we have this part empty. The final problem is left to you. If I give you a hint, this will be useful. Let's go to the next example. This time, we have to do an appropriate setup before starting the manipulation. Previously, we could just go right ahead, but this time it's going to be a little bit difficult to manipulate this square root. So we need appropriate setup. By the way, this is a suggestion. First setup, second manipulate, and third conclude. So setup, how do you set up? Square both sides, and you're going to add to this inequality, and that's the starting point. This is logically the same as this, logically equivalent to this. So that's a setup, and then you can do algebraic manipulation from here. We went through a couple of directions, starting from the left-hand side and manipulate, eventually go to the right-hand side, or vice versa. From the right-hand side, move on to the left-hand side. This time, we're going to do neither. We're going to do left-hand side minus right-hand side, and then eventually work out, and greater than or equal to 0. Please check out. Expand, simplify, take the like terms, and then further manipulation, we have complete square, so that's greater than or equal to 0. And also, please note these. All the equalities here, they're all aligned, following the grammatical rule for proof writing. And then this part stays empty. We're going to use this a little bit later again, so let's copy and paste it. And as a matter of fact, that's enough, but we can go for one more step to conclude. As for the other problems, well, I'll just leave you with these problems. For the second problem here, you can do appropriate setup, square all three, and then we have the first inequality and the second inequality. We have to prove the first one in step 2 and second one in step 3. Good luck about that. They're not difficult, they're elementary, but a bit tedious. Now, let's go to an incorrect proof. I see these kind of things a lot. Here's an attempted proof of this, which is, as a matter of fact, an intermediate step of, oh, not this problem here. Yeah, this one here. And then here's the proof. This is correct proof. Yes, okay, let's copy and paste this. And then let me show you the wrong proof. Okay, why is this wrong? And why is this correct? I just copied and pasted from the previous proof, so this is correct. Please compare this and that. What is wrong? If you look at all the algebraic manipulations, folding and the subtraction, taking the like terms, manipulation, complete square, they're exactly the same. As for the alignment, okay, all the alignments here, according to the equality, here inequalities are all moving around, but then again, they're all aligned from the left-hand side. So alignment is not that bad either. What's the problem? Here we have one inequality here, another inequality here, third inequality there, fourth inequality, and fifth inequality. How are they related? They are separate inequalities. They are independent inequalities, and there's no explanation how they are related. That's why this is imperfect proof. Just checking process, just algebraic manipulations only, not a proof. How does the first line generate the second line? Second line is related to third line, in which sense? It's not clear. So this is just a checking process, not a proof. One way to make it right is to change the structure into a proof by logical implication, like this. Exactly the same, but what did I do? I put this logically equivalent notation here. So what do I have here? The original is equivalent to this first line, and that's equivalent to the next line, and that's equivalent to the next line, and so on, and eventually we got to that. And the final line is always true because the left-hand side is a complete square. Consequently, all these are true because they're all equivalent. So it works like this, and please note that this proof by logical implication follows more or less the same grammatical structure as the proof by manipulation we discussed before. Instead of equalities, we have logical equivalences. They're there and they are aligned, and then this part is left empty. So this entire thing is actually one big logical identity equation. So this isn't one big logical equation. Oh, did I say logical? Sorry. This is one big algebraic equation. In the end, it became inequality. And this one here is one big logical equation, and we follow the same logic, same grammatical rule. All these aligned and then kept empty. So the first line is equivalent to the second line is equivalent to the third, and so on and so forth, and then final line, that's always true. So all these are equivalent, so all these are always true. So the grammatical rule, alignment, not too much of a big deal. Empty, that's a big deal. Remember those. And if you write down what is the reasoning, that of course will improve further. Do you have time for another example here? How about this? Here's a wrong proof. Okay, all right. Proof of this. We have all the correct algebraic manipulations, and then all these inequalities are aligned, but this is not a proof. This is just a checking process. Correct it. You can either change it into a proof by algebraic manipulation, or you can change it into proof by logical implication with some equivalence notations over here, like these. So this is equivalent to the second. That's equivalent to the third. I'm getting tired of those. Equivalent, equivalent, and equivalent. By the way, this double arrow notation with this, and then these two notations are the same. They both mean the logical equivalence. So biconditional statement is tautology, always true. And here left hand side and right hand side are logically equivalent. They mean the same thing. So you can make this right by putting these in there, or you can restructure and make it into a proof by algebraic manipulation. We have another problem here. No more problem. And then there's some leftover problems here and there, like this one, or this one. Those kind of things are left as an exercises. Okay, so much for proof by algebraic manipulation, and we are going to talk about other proofs in separate videos.